projects. In this video, we are going to explain about the project that is forecasting a journal impact factor under missing values based on machine learning. Before getting into the execution, first let us understand what is the project about. Journal impact factor, that is called JIF. It is an important metric that helps to assess the influence and significance of scientific journals. For researchers, choosing the right journal to publish their work can be daunting task, and JIF plays a big role in that decision. A higher JIF typically indicates that journal is well respected and widely read. This makes it an attractive option for researchers. Similarly, institutions and funding agencies also use JIF to evaluate the impact of research and make decisions on funding allocations or promotions. However, there are several challenges that comes with using JIF. First, JIF can vary greatly across different research fields. This makes it difficult to compare journals from different areas of study. Additionally, JIFs of a journal is not fixed and it can fluctuate over time. This fluctuation is often due to changes in citation patterns, editorial decisions, or the type of articles being published in a given year. And the other issue is with the missing data of some journals. This is especially problematic for new or less established journals where complete data might not be available or consistent. For researchers, particularly those who are starting their careers, these challenges can create confusion and they can delay the journal selection process. Without accurate or comprehensive data, researchers might waste time on journals that are not a good fit for their work or they are less likely to accept their papers. Even though JIF has become a crucial factor for researchers, when choosing the journals, there aren't many studies that focus on predicting JIF values. Especially when dealing with the missing data, this gap in the research is a problem because without accurate JIF predictions, researchers struggle to make well informed decisions about where to submit their work. For example, if they can't predict how a journal's reputation might change over time or if some data is missing, they could end up wasting time or making poor choices. This highlights this highlights a bigger issue. There is a need for a more complete solution that can predict JIF accurately when some data is missing. By addressing these gaps, researchers would be able to select journals more confidently and strategically, improving the efficiency and effectiveness of the academic publishing process. So, to overcome with all these issues, the proposed system is designed to predict the reputation of journals measured by journal impact factor. One of the main challenges in forecasting JIF is with dealing missing data. One of the main challenges is dealing with this missing data, which can impact the accuracy of predictions. So, to solve this, the system uses a technique called KNN based imputer, which is K nearest neighbor based imputer, which is a method for filling in missing values by looking at similar data points. It works by finding neighbors in the data that are most like the missing entries and using their values to replace the missing ones. This approach is more accurate than traditional methods like using mean, median, and MICE. MICE is multiple imputation by chained equations, which simply fill in missing data based on average values or assumptions. By using KNN-I, that is KNN-based imputer method, the system ensures that imputed data is more realistic and better reflects the underlying patterns in dataset, which leads to more reliable JIF predictions. So, how this works? It works through a series of steps to ensure that the data used for predictions is reliable and possible. First, first we address the issue of missing data. Instead of simply ignoring the missing values or filling them with wrong, that is rough estimates, the system uses KNNI, that is K nearest neighbor imputation algorithm. This method looks at surrounding data points that are more similar to the missing values and uses them to fill in the gaps, which results in more accurate and realistic values. Then comes the second part. Here, next, once the missing values have been properly filled, the system we use machine learning models to make predictions, specifically support vector machine, that is the support vector algorithm, SVM, which is known for its ability to handle complex patterns in the data. By training the SVM now on the complete data set, the system learns how to predict JIF values based on pattern identifies. Finally, The system evaluates how well it is performing. It measures the accuracy of predictions using two key metrics. One is root mean squared error and mean absolute error. The goal is to minimize these errors as much as possible, which means that predictions are becoming more accurate and reliable. So this is the proposed system. Moving on to the extension part to further improve the accuracy. Here, support vector machine, that is the support vector algorithm, is fine-tuned by the parameters that are C, maximum iterations, and cache size. C balances the margin and classification errors while the other parameters control the algorithm efficiency. These optimizations lead to better performance, reducing prediction errors, that is RMSE and MAE, and enhances the accuracy of journal reputation forecasting. And here, user-friendly interface has been developed using Flask framework, providing a secure platform for researchers to log in, test the system, and evaluate its performance. This interface makes the system more accessible and practical, allowing users to easily input data and assess how well the system predicts the journal reputation, ensuring usability. Moving on to the implementation. To implement, we have followed the steps in the flow of work. So first, we have imported all the required libraries and packages into the project environment. Later on, the dataset containing journal information is loaded into the system for further analysis. After that, we have explored the dataset. Here, initial exploration of the dataset is done, which helps in understanding its structure, identifying important features, and spotting any issues like missing values. After that, we have done data pre-processing, where we have converted categorical data into numerical format using label encoding. Then we have handled missing values using two methods. One is k-means, KNN based imputer, and the other one is mean. After that, we have normalized the data. Here, data is scaled using min-max normalization to bring features to common scale for better model performance. And then comes the data splitting part. So the data set is divided into training and testing subsets to evaluate the model performance. Training set is used to train the model and testing set is used to evaluate the model on unseen data. Then comes the model building. Here we have initialized the SVM model. After that, initialized model is trained with two data sets. That is with mean imputed data. So the SVM model is trained on the data set with mean imputed values. And we have also trained SVM model on the KNN imputed values of the data set. After that, the SVM model is further optimized by adjusting hyperparameters to improve the accuracy. This is the extension part. And we have evaluated SVM with all the imputed values using evaluation metrics, that is RMSE and MAE. After that, a user-friendly frontend is developed using Flask framework with a registration and login system powered by SQLite to manage its user data. And in the front end, users they will be able to provide feature values and that will be pre-processed at the back end and it will be fed with the train model. Finally, train model will be giving us a prediction and that will be displayed to the front end of the application. So this is how we have implemented the project. Moving on to the algorithms used. So these are the algorithms used. So first we have trained SVM with the mean imputed data and then we have trained SVM with the KNN imputed data and we have optimized that SVM KNN imputed data. We have optimized the SVM model with the hyperparameters. Moving on, to implement this project, we need hardware requirements, which are we need basic requirements, which are hardware and software. So coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB, and hard disk of 25 GB. Coming to software, we need application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now, let us execute. For that, we are supposed to open the code folder which contains source code files. So these are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? Here in this dataset folder, we have the dataset used in this project. So this is the data that is used. Let us open. So these are the different attributes based on which we will be predicting the journal impact factor. So this is that target column and remaining columns are the attributes. Except B, all the remaining B columns are the features. Based on that, we will be predicting this impact factor. So we will be using this data to train the model so that we will be able to predict this impact factor. That is JIF. Let's close this. And here in this test data file, we have the test cases that we will be using in the front end to predict the journal impact factor. Let's get back. And moving to the model folder, in this we will be having .h5 files, numpy files, and pickle files in which algorithm information will be stored. And that will be loaded into the project code during runtime of the application. And next file we have is a static folder This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And then we have the templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And we have app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have notebook file. This is the notebook.ipynb file, which is a Jupyter notebook file. And this contains combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, which makes it a popular choice for the data science. And here last file we have is the signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let us execute. For that, copy the path of the code folder from the address bar of the file explorer. I'm copying it. Now open the command prompt. It has been opened. Give it the command cd, give the space, paste the copied path, and now click on enter. Here current directory is changed to the code folders path. Now we are supposed to compile app.py file. So give the command python space app.py and now click on enter. This command, it will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port unless configured differently. So this is the localhost and this 5000 is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I've copied it. Now open Chrome because I prefer that. Your choice, you can open it any web browser and paste the link here. Click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So sign up first, click on sign up and enter all the registration details if you are registering newly. I have already registered, so I will directly sign in, click on sign in and provide your credentials, which are username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see choose file button, right? We need to click on that for uploading the test case file. So click on that. So this is the file that we are supposed to upload. Select it, click on open, and here we are supposed to click on upload. Before uploading, let's see what do we have in this test data file. Get back to the application, that is code folder, open the data set, open the test data file. So this is the test data. And here these are the different test cases that we will be uploading now. And here we have different attributes. Based on these only, we will be predicting the journal impact factor. So first we have is the journal name, that is the name of the academic journal. And then we have source, it is the origin or the database providing the journal data. And then we have type, it is a type of category of the journal. And then we have title, it is the full title of the journal. Then we have publisher, it is the organization or a company responsible for publishing the journal. And then we have ISSN, that is the International Standard Serial Number, which is a unique identifier for the journal. And then we have DIOS by year. So this is the DIOS by year. It is a number of DOI, that is digital object identifiers assigned to articles in the journal annually. Then we have bag file DOIs, that is DOIs. It is the total number of DOIs from the journal's historical archives. And then we have current DOIs, that is the number of DOIs currently assigned to the journal's articles. And then we have total DOIs, that is the cumulative count of DOIs across all the years of journals. And then we have subjects. It is the field or discipline that the journal focuses on. And then we have impact factor. And then we have, this is the impact factor. It is the another metric representing the journal's over impact or reputation. And then we have journals. It is the journal metadata. So it is the file paths or metadata associated with the journal for tracking the documentation purpose. So this is about the factors. Now let's get back to the application. Click on upload. And here the given data will be pre-processed at the backend and then it will be fed with the trained model. Then we will be getting the prediction accuracy. So here we got the predictions. So here you can observe that we have uploaded a number of test cases and here we got the predictions. For each case, we got the prediction. So here, this is the first case that we have uploaded and here are the different attributes and it has been predicted. So here, forecast of journal impact factor has been predicted as 2.03. So here, journal impact factor has been predicted as 2.03. And next, this is the second test case that we have uploaded, and here we got the prediction that 1.46. And here for this case here 2.74 has been predicted, and for this 3.11. Based on the journal, we got the prediction. We can see for some journals we have 1 point and with the decimal points, and for some test cases we have two with the decimal points, and for some cases we have three with the decimal points. And now let's check with the graph. Click on graph. So here the first graph which we have is the extension optimized SVM KNN imputation journal impact factor forecasting graph. Here in this graph, red color represents the true JIF and green color represents predicted JIF. Here on x-axis we have total number of test samples, and on y-axis we have journal impact factor. If you observe, red color and green color, they are almost correlating with each other. That means they are completely mixed. It means that it is correctly predicting. It is predicting the actual values. So by this we can understand that the extension SVM KNN model is performing well. Moving on to this graph, this is the MA, that is mean absolute error. Here on x-axis we have the error rate of each model, and on y-axis we have the algorithms that are trained on the data set. Here if you observe, this is the SVM mean imputation model, this is the SVM KNN imputation, and this is the SVM extension optimized SVM KNN imputation. Here if you observe, extension model has the least error rate. And here this is the RMSE comparison graph. So here on x-axis we have root mean squared error. RMSE refers to root mean squared error, and on y-axis we have all the algorithms that are trained. And here also if you observe, extension model has the least accuracy. Now click on sign out. In this way, just by giving required parameters to the system, it will predict the journal impact factor. This is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.